7th grade, welcome back. Today we are starting section 6.5, which is called the x and y intercepts of a line. Okay, so for this video, right, this is like a two-part series. So I'm going to be doing a PowerPoint video, as you see, and working through some problems with you through the PowerPoint and also the webcam, okay, which is in the lower right-hand corner. And then once I'm done with this PowerPoint video, the second video, all right, will be from the textbook. Okay, so this is the first video that you want to start with, all right? So take out your notebooks, hopefully you're ready, and get ready to take some notes. Just a reminder, at any point if I'm going too fast, you can pause this video to get caught up with your notes, okay? So in 6.5, we're going to learn about the x and y intercepts of a line. But before we do that, I just want to remind you about linear equations. That's what we're talking about in this chapter, okay? So a linear equation is just a fun way of saying a line on a graph. But for a linear function or linear equation to be linear, it has to satisfy certain characteristics or traits, okay, of linear equations. So the 5 traits that it needs to satisfy are: the equation includes an x and y variable, so that's the first one. So in order for it to be a linear equation, it has to have both an x and a y variable, okay, or a and b, or c and d, any type of combination of variables, but there has to be 2 of them. The y variable is risen to the first power. The x variable is risen to the first power. Neither the x nor the y variable are in the denominator, and the x and y variable are not multiplied by each other. All right, so if we look down here, right, that all kind of sounds gibberish. So I think it helps if you look to see examples of a linear equation versus a non-linear. So if we look over here, in the first column it says examples linear. So here I have 3x plus 2y equals 10. I know that this is linear because x is singular, right? It's just x to the first and y to the first. They're not being multiplied together, they're being added, which is totally fine. Okay, this is standard form, if you remember, ax plus by equals c, right? Neither the x nor the y denominator are in the denominator. So therefore, and there's an x and a y. So this satisfies all of the characteristics of a linear equation, and therefore it's linear. The next one, right, I have x and y. They're not being multiplied together. They're both single x and single y, which means they're x to the first and y to the first. They're both being raised to the first power. And again, neither of these are in the denominator. So we're good. The third one, negative y equals 7x. That's totally fine. We can just divide everything by -1 and get positive y, right? You could actually solve for y here. Y and x, though, are not being multiplied together. They both have a power of 1. And neither of them are in the denominator. So therefore, all 3 of these are examples of linear equations, okay? If I come over here to not linear, here I have 3 times x times y in one term. Right there I would stop. X and y cannot be multiplied together, so therefore this is not linear. This would form a different shape in our graph, okay, if we were to graph this equation. Here, y equals 3x to the 5th plus 7. This is not linear, because x cannot be raised to the 5th power for it to be a straight line. This needs to say x to the first, so this would not be linear. And then my last one, y equals 9 divided by x. This is not linear because x is in the denominator. And if you look up here, we said neither the x nor the y variable are in the denominator. So therefore this would not be linear. Okay, now that we just recapped the characteristics of a linear equation, and again, you want to write these down if you haven't already. I'm going to move on to the next slide, and again, if you need more time, just pause right here and take the time to write down these examples. Okay, so now we're going to move on to the definition of an x-intercept and a y-intercept. Guys, this is so easy, okay? So when I draw a line, my x-intercept is the x-coordinate of the point where the line crosses the x-axis. What this means is, if I look at this line, I want to ask myself, where does this line cross the x-axis? So if I go left to right, this line crosses the x-axis at 2, so therefore my x-intercept is 2. And the coordinate would be 2, 0. Again, x-intercept is intercepting, right, or intersecting, I should say, the x-axis. The y-intercept is the y-coordinate of the point where the line crosses the y-axis. So again, all I'm doing is asking myself, where does this line cross the y-axis? So when I look here, if I go from top to bottom and I look, all right, this line crosses the y-axis at +3. So the y-intercept for this line would be 3. Okay. Here we go. So my next set of directions says, find the intercepts from the linear equation y equals 3x minus 9 without graphing. So in this last example here, they gave us a graph. This is really easy to tell what the x and y intercept is, right? You just look at the graph, and again, the x-intercept is 2, the y-intercept is 3. But here, they're not giving us a graph, they're just giving us a linear equation, y equals 3x minus 9. And they want you to come up with the x and y intercepts. So to find the x-intercept of y equals 3x minus 9, you're going to substitute 0 for y. So if you're looking for x, you want y to be 0. And the reason why is, what did I say on this last slide? My x-intercept, right, because it lands on my x-axis, y is always going to be 0. So by substituting y for 0 here, that's now coming up where they're solving for the x-intercept. And then it's going to be opposite for the y-intercept. So for the y-intercept, I'm going to substitute x for 0. And again, on my last slide, when I look here, my y-intercept, my x-coordinate here is always 0 because it lies on the y-axis. All right, so again, to find the x-intercept for y equals 3x minus 9, you're going to substitute 0 for y and then solve for x. So to do that, over to the side here, all right, again, this is to find the x-intercept. To find the x-intercept, can you guys see that? I hope you can. For y equals 3x minus 9. And then to find the y-intercept. Alright, so this is what I'm solving for. To find the x-intercept, okay, I'm going to substitute 0 for y. So instead of y, I'm going to put a 0. And that's going to be equal to 3x minus 9. You guys see that? It looks blurry. Okay. And then I'm just going to solve for x, just like I would for a two-step equation. Okay, so I'm going to get x by itself. So I'm going to add 9 to both sides. So now I have 9 equals 3 times x. And again, I want to get x alone. So now I'm going to divide by 3, divide by 3. So my x-intercept here would be x equals 3. And then for my y-intercept says, because I'm looking for y, I'm going to substitute 0 for x. So again, if I'm looking for y, x needs to disappear, and I'm going to substitute it with 0. So 3x minus 9 becomes 3 times 0 minus 9. And now I'm just going to solve. This one's an easy one. Y equals 3 times 0 is 0 minus 9. So y equals 0 minus 9 is negative 9. All right, so for this linear equation, my x-intercept is 3, and my y-intercept is negative 9, which means that this line crosses the x-axis at 3 and the y-axis at negative 9. And if you were to connect those 2 points, that would be your linear equation. So here are some more examples. I'm going to walk you through them. I just feel like this is not... Let me try to adjust this lighting a bit. Can you guys see that better maybe? There we go. That looks better. Okay. I'm going to do a couple of these examples with you, okay? So, again, I'm trying to find the x and y intercepts for the following linear equations. So, I'll switch it up. Let's do blue. All right. My first problem here, can you guys see that? No. Is negative 3x minus 7y equals negative 84. So again, my directions are to find the x and y intercepts. Okay, so if I want to find the x-intercept of this equation, y-intercept, to find the x-intercept, I want to keep x and substitute y for 0. So when I rewrite this, I rewrite negative 3x minus 7. Instead of y, I'm doing times 0 equals negative 84. And the reason why I put parentheses around this, you guys, is just to tell you that you need to multiply. This is 7 times y. So if I substitute 0 for y, it's going to be 7 times 0. And now I'm just going to simplify. Negative 3x, negative 7 times 0 just cancels out, and that gives me negative 84. Okay, and now I'm just going to divide this side by negative 3 and this side by negative 3. So then a negative divided by a negative gives me a positive. And 84 divided by 3 gives me 28, I believe. 20, 40, 60. 28? 24, 60, 24, yeah. Positive 28. So my x-intercept for this line would be positive 28. My y-intercept, okay, my y-intercept, because I'm looking for y here, I'm going to substitute x 0 for x. So when I rewrite this, negative 3 times 0 minus 7y equals negative 84. Negative 3 times 0 just gives me 0, and I'm left with negative 7y. Okay, and now I'm just going to divide both sides by negative 7. Okay, so then I get y equals a negative divided by a negative is a positive. And 84 divided by 7 gives me 12, right? I believe. No, that's a lie. Not 12. Back it up. Oh, wait, yeah. Yes, 12. Sorry about that. Oh, boy. I feel put on the spot in this video. It's kind of funny. Okay. Can't really make mistakes, but I don't know how to rewind, so here we go. All right, so my x-intercept is positive 28, and my y-intercept is 12. You guys see that? Which means this line, negative 3x minus 7y equals negative 84. This line, if I were to plot this line on a graph, it would intersect the y-axis at positive 12 and the x-axis at positive 28. Okay, you guys, I'm running out of time because this thing only lets me record to 15 minutes. So I'm actually going to do a part 2 video to this PowerPoint, simply because there's a second way I can show you how to solve for the x and y intercepts that might actually be easier for you. Okay, so look for part 2 to this video. So there'll be 3 videos, if not 4 altogether for this section. Fun times. Okay, so I'm going to pause this, save it, and start off again for the video that says PowerPoint 6.5 PowerPoint Part 2.